So Kayla sent me a couple questions based on this 5.2 packet, and I'm going to try and answer those as best I can. So just bear with me, and I might be having to toggle back and forth to see what her questions are in my screen here. I think her first question was, are you always going to be provided Ka? When we're doing any kind of buffer titration calculation. So just remember that a buffer and titration calculation is nothing more than kind of a fancy acid-base equilibrium. And the three main variables in those problems, because we got Ka equals H plus A minus, or products over reactants, right? And if we know H plus, then we can find pH. So essentially the three variables that we could potentially have here are going to be Ka, H plus, or pH, I suppose. So those kind of go hand in hand, because if you know one, you can find the other, and or HA concentration. So as long as you know two of those things, you can find the other. And I know some of these questions on this page may or may not have included the Ka, but that's because this was something that you could have looked at a reference chart to find a Ka. So if you're not like the appendix in your textbook, so appendix, I think it's appendix D towards the back, has a list of all the K values, excuse me, both Ka and Kb. So if you're trying to work out a problem and they don't tell you what it is, then you can look that up. But if this was on the AP test, assuming we still get to take the AP test, I don't know what that's going to look like yet for you guys. You would be provided either Ka and pH or pH and HA, because as long as you have two of them, you can solve for the third. So that was her first question. And then the second question she sent me in her email had to do with question number 4 in here. And I think it's the fact that there was 2 rice charts. Like, what's the purpose of the 2 rice charts? And the purpose of the 2 rice charts, you have to recognize that there's a couple things going on here. So question 4 is the one that says benzoic acid is a weak acid. I'm just going to call that HA. And it has a Ka of 6.4 times 10 to the negative 5. It tells us that the equivalence point happens, and we talked about this. The equivalence point is, if we're doing kind of a generic titration, the equivalence point happens right here, and this is where moles of acid is equal to moles of base that was added during the titration. So the equivalence point happens when we got 25 milliliters of 0.1 molar HA, so that benzoic acid, is titrated against 0.050 molar sodium hydroxide, which is a strong base. So this is a weak acid, strong base situation. So the question is, calculate the pH. Like, what's happening? What is the pH of this solution at the halfway and the equivalence points? So if this was, I guess I should have corrected my little graph here. If this is a weak acid, strong base, it's got that little like weird lip there. That's indicative of a weak acid happening, because the pH rises kind of really fast at the very beginning, and then it starts buffering in this region. And so whatever this volume is, volume of this base, this is where the equivalence point happens. That's where we see that moles of acid equals moles of base. Well, halfway to whatever that volume is called the half equivalence point. So this right here is our half equivalence point. And there's something interesting about that half equivalence point, because the half equivalence point, at the half equivalence point, I'm going to say HEP. This is where, if we think in terms of the Henderson-Hasselbalch, the concentration of HA, which remember is weak, is equal to the concentration of A minus. And according to Henderson-Hasselbalch, if that's true, A minus over HA, this whole term is zero. Because if A minus and HA, now remember, this is coming just from the benzoic acid, the weak acid. This has nothing to do with the fact that we've added NaOH to it. But once we add the NaOH to it, then we get to the point where these two species are equal to each other. And so if these are equal to each other, A minus and HA, that makes this term 1. Log of 1 is 0. And so at the half equivalence point, this relationship is true, where the pH equals the pKa. So finding the pH at the half equivalence point is really easy, because they told us what the Ka was. So if pKa equals negative log of the Ka, then we can just plug that number in to find what pKa is, and I got it to be 4.19. That may be off, give or take, what the key says. I'm not sure. I don't have that in front of me. But since pH equals pK, then we can infer that that must be the pH at that point. For the equivalence point, it's a little tougher, because we got to do some rice chart business. And kind of the whole purpose of showing the two rice charts is so that you can understand what's going on. You don't necessarily have to do both of those rice charts to be able to fully answer this question, but for you to have that conceptual understanding, that's more the reason why you see those two rice charts. So at the equivalence point, we know that moles of acid equals moles of base. We mentioned that up here. Another way to say that is molarity of the acid times volume of the acid, because when you multiply molarity times volume, that's the same thing as saying moles, equals molarity of the base times volume of the base. And we know 3 of these variables. They told us that the equivalence point happens 25 milliliters of acid. So like in our titration right here, we put 25 milliliters of this acid, and it's 0.1 molar down here in the flask. And then up here in the burette, we have 0.050 molar NaOH. And so we're going to let this drip down in here until we see that color change, based on choosing our indicator. And again, we're going to pick an indicator that changes color somewhere in this vertical region. So we'll have an indicator in there, and it'll change colors, and we'll know where to stop our titration. And once we stop our titration, then we can figure out how much we put down in there. But we don't actually have to do this titration to be able to calculate what that expected volume of base is supposed to be. We can just plug these numbers in to this equation. So the molarity of the acid is 0.1. The volume is 25 milliliters. We set that equal to the molarity of the base, which is 0.05, and then solve for the volume of the base. And you can handle that algebra pretty easy, I'm sure. So the volume of the base that it takes to make this get to the equivalence point is 50 milliliters. That's how much sodium hydroxide we have to add to get to that equivalence point. Well, at the equivalence point, what's happened is we have our acid reacting with our base, and I'm just going to write it as, here's our weak acid, and here's the hydroxide. The sodium ion is just a spectator. So when those things are reacting together, they make water. And what else happens? This produces A minus. And so that's how we know we have a buffer, because we're going to produce this, and it's all going to be present at the same time. Well, what the first rice chart is really trying to get you to understand is think about how much HA we started down here. And let's think of it in terms of moles. I'm going to calculate it in millimoles. So 25 times 0.1 is 2.5 millimoles. So we started with 2.5 millimoles of acid down here. And then after we add 50 milliliters of 0.05 molar sodium hydroxide, that's equivalent to 2.5 millimoles of base. So that's what we've done. We've mixed those two things together. So these two things are neutralizing each other. So if I subtract 2.5 millimoles away from the acid, because that's how much it takes to neutralize this base, and I subtract that same amount away from the base because that's how much acid it takes to neutralize the base, then that means I'm producing 2.5 millimoles of this A minus. And these guys are just zero. Like, this has been completely used up because it's neutralized the base. So now the only thing present down here at this moment in time is 2.5 millimoles of A minus. Well, that's when we flip this reaction around, because the A minus can still do some stuff. It can still do some stuff. Like, it can still cause some reaction happening down here if that's the only thing that's left. And so now what we do is we write it as A minus plus what's it doing down there in that beaker. Well, now it's going to do some stuff with the water. And the A minus has the ability to accept some hydrogen to make HA. Now remember, it's not going to do that like very well because it's a weak acid-base situation. And then we get some hydroxide. And so this is where now we do our second Rice table, because this amount is the amount that we have in the beaker at this point in time. But when we're doing a traditional Rice chart, we want to go ahead and convert this back to molarity. So if you think about this, we have 2.5 millimoles of A minus over what was the volume? Well, we started with 25 milliliters of HA. We added 50 milliliters of OH. So the total volume now down here in this beaker, this flask, is 75 milliliters. So when you recalculate that, that's going to tell you what the concentration of A minus is in that flask. And I got that to be 0.033. And then from here, it's just like a regular Rice chart. So at this point in time, if we stop the titration exactly right there, this is how much we would have, and there would be none of these things. So there's none of this. Then we reduce by X, increase by X, increase by X, 0.033 minus X, X and X. Sorry, I'm running out of room here. And then we can set up our K expression. Now this is going to be a KB because we're producing hydroxide. So KB equals concentration of HA times hydroxide over concentration of A minus. And then we plug these things in because they told us what the Ka was. So we can convert Ka to Kb because remember, Ka times Kb equals Kw, which is 1 times 10 to the negative 14. So divide Kw by Ka to get your Kb, and then solve this like normal. And once you solve this, you're finding hydroxide. And just remember that once you have hydroxide, to find pH, it's 14 plus the log of the hydroxide. So this video is long enough, so I'm going to stop this one here, and then I'll record another one answering the other questions.